Hello everyone. Today we'll be talking about exponents and radical. Hopefully, all the previous topics we have learned, your idea of the topics and everything is very clear. If you have any question regarding any topic, you can just write in the comment section or write an email to me, mathwithhafiz@gmail.com. Let's talk about another chapter, one of the important chapter which is exponents and radical. Most of the people they have confusion about what is radical and what is exponent. So radical is anything which is written in this form. Let's say it is square root of x. Anything which is in the root form, it is called radical. And if I want to write a radical of nth root, so I will just write an n. If there is nothing there, like this, there is nothing here at the top. So it means I just circle it to show like there is nothing. So it means this is a radical with 2 power. So it will be equal to x is equal to 2 if it is just like this. And if not, if I mean there is nothing here. So if not, it will be equal to x to power of n. This is how you convert from radical expression to exponents or vice versa. So let's move to the rules which we are going to study today. So the rules we are going to study are, okay, I was just changing it there. First of all, we have a product rule in which this is product rule. And this product rule actually tell us what to do when we have two things, they have same base, what you have to do. For example, you have an x multiply by you have x square. So it will be equal to, you will add their powers, so it will be x to power of 1 plus 2, which means x to power of 3. So this is how you will solve these type of questions. Let's talk about next rule, which is called quotient rule. Anything in division, you will add their power. The only condition for both of these rules is that both numbers should have the same base. Here they have m base, a base, and a base. So for these two rules, the base should be same. If it is x multiplied by y to power of 2, you will just write it as xy square. You will not be able to convert it. Then we have a rule for power. If you have power, the powers will be multiplied with each other. Let's say we have x to power of 3 whole to power of 2. So it will be x to power 3 multiplied by 2, which will be x to power of 6. And again, if you have two numbers sharing the same power and they are in multiplication, remember this, the product rule, whenever I used to teach this product rule, the students always used to mistake. They put this product rule as a plus b whole square. They will write it as a square plus b square, and this is totally wrong. So you cannot do it. The only thing is this product rule or these quotient rule is only valid. This type of rule, either the things are in multiplication or the things are in division. So it means if there is no plus or minus sign in between them, then you can use this power rule. Otherwise, you cannot use it. So you have to keep these things in mind. Then we have Then we have this zero exponent rule. Anything to power zero is one. Whatever the number is, if it is having power zero, it means it is one. And now it comes zero to power zero. It can be one, it can be infinity, depending on the situation. We are not going to deal with that. So the last thing which we have is fraction, fractional exponents. If you have anything, how you can convert this into from exponent till into radical form, we will learn it. That's why I'm not going to explain this here. When we'll solve the example, it will be more clear to you. So let's say we have this exponent and they are asking us to simplify the expression For example, this is an expression. This is an expression where we have 2x to power of 3, y to power of minus 3 multiplied by 2, x to power minus 1, and y to power of 3. So what we are going to do, we are actually going to use this all concept which we just learned, the rule, the basic rule, to overcome this question and simplify it. So 2 with goes with 2, 2 multiplied by 2, x3 will be multiplied by x to power of minus 1. The same way base will be multiplied with each other. Then we will have y minus 3 multiplied by y to power of 3. So first of all, we will solve this. 2 multiplied by 2 is 4. Now here we have same base and their power is going to add according to the rule. So it will be 3 x to power 3 plus minus it will be minus 1. Then we have y to power of minus 3 plus 3. Hopefully it's clear because whenever we are adding something, we are multiplying something with the same base, their power should be added. So, so the answer of this will be 4 x to power of 2 and y to power of 0. So y to power of 0, it will be 1. So we don't write 1 in multiplication, so we can write is equal to 4x squared. I think it's clear. It's easy. So now come to the second question, which is in the exponent form, and also it is a rational number. Okay. So what we have to do, we have to use the quotient rule. Remember, so it will be I will separate these numbers. What are the numbers? It is 4 over 3. We cannot simplify it, so why not to keep as it is? Now I will move all the numbers m to power of 4 and m to power of 2. Whenever we move something with the power from denominator to numerator or from numerator to denominator, like I'm moving something from up to down or down to up, I have to change the sign. So it will be m to power 4 minus 2, or you can just use quotient rule. No need to worry about your brain or remember something. Just use quotient rule. So in quotient rule, if anything is in division, you will subtract them. N to power of 3 minus 2, p to power of 3 minus 4. Okay, so it will be 4 over 3. I'm sorry, I am actually writing very fast, so I'm just missing the word. So m to power of 4 minus 2 is 2. Then we have n to power 3 minus 2, which will be n to power of 1, and we do not write 1. Yes, you are right. Then we have p to power of 3 minus 4, it will be a negative 1. So as it is negative, to make it positive, we have to move it down. So it will be 4m square and over, I'm sorry, over 3p. So when I move p down in the denominator, the negative will become positive and we do not write 1. But remember one thing, we do not write 1. But if it is negative 1, you have to write. We should write. My handwriting is, I don't know how it is going. Anyhow, I think this was pretty easy for you guys. Then simplifying rational into radical expression. As I mentioned earlier, how we can simplify from radical expression to exponential. Okay, rational to radical expression. So what we are going to do, this is n to power of 4, 3 by 2. Remember the power rule, whenever we have something outside, we just multiply it. So it will be n 4 multiplied by 3 by 2. Simply, whatever you have power, you will multiply with this power. And how we can simplify it? 4 divided by 2, it will be 2. Okay, there are two ways to simplify. One is you divide it. Okay, I will, if I can change it. No, I cannot. So, okay, so one way is I will divide this 4 by 2 and it will give us 2. Then I multiply 2 with 3, it will be n to power of 6. But in case there is addition subtraction, then it is confusing for some students. So I would say if you have such confusion and you think you are not good with that, so I would say go with the Demas rule. This is by the way Demas rule, division, multiplication, but you cannot divide 3 by 2. So you can follow the rule actually. What is that? You have to multiply first, then you can look for the division because the division is on this number only right now, on this number only. It is not a whole. So it will be 4 multiplied by 3. It will be 12. Yes, you are right. Then it will be divided by 2. I'm considering you are actually answering me. Actually, none of you is actually answering because you are just watching a video. So it will be 12 divided by 2 and is equal to 6. So both ways are fine. Whatever ways you like and you think you are comfortable with, you can go. Here it is a bit long question. So let's deal with it. To remember constant with constants, variables with variables. So variables are same. So it will be 2 plus 3 by 2 plus minus 2. So it will be 2 multiplied by 4, 8 multiplied by 4 is 32. M2 and minus 2 will be cancelled, so we will have m to power of 3 by 2. Now, if the question is saying convert it into radical expression, here we did not had anything radical, so it was fine to write like this, but here we have to write 1 by 2 as a radical, so we can write as 32 square root of m cube. Remember, I told you if there is nothing here, so it means it is a square root and you will write the power 1 by 2. So this is the example of that. Hopefully it is clear to you. If you did not understand any question, you can ask. This lesson is going to be long because there are something which I plan to teach you, which are actually skills you will be using while solving such type of questions from this chapter. Okay, this is a bit, it seems to be scary. I always give these type of questions and my students mostly they were like, what is this? It is very hard and we cannot solve it. But actually they do not try to solve it. So I'm going to teach you how can you do it. Simply do not need to worry about. So first step is there is a power outside, two numbers in multiplication. Leave everything aside in the numerator and deal with it. So it will be x to power minus 1 by 2 multiply by, remember, if the number is outside of the bracket, we have to multiply. Yes, you are right. So it will be x to power of 4 multiplied by 1 over 4. I did not do anything very complex. I just took the number and multiplied by using the rule which we already studied and we already did practice for. Now, in the denominator, I would suggest what you can do to make it easy, check if they are same variables. If they are same, just use whatever if they are in multiplication. So what you can do, you can add their coefficients, right? So it will be x to power of 2 over 3 minus 3 over 2. Remember, this negative sign is coming because it has negative sign. Otherwise, there will be no negative sign. And same thing goes with this one, y to power 3 by 2 into 1 by 2, and it will be addition. Okay, now what we could do is also this is 3 by 2 and whatever we are going to get from here it will be also something like this. So let's deal with it. So it will be x to power in the numerator, x to power minus 1 over 2 multiplied by 4 is 8 and y to power of 1 do not do this mistake, which my student usually does. This remind me of that mistake. They would cancel this and they will write y to power of 0, which is wrong actually. It is 1. Okay, so you have to subtract it. You cannot. You will make same denominator, multiply by 2, multiply by 2, multiply by 3, multiply by 3. So you will have x to power of 6. It is the same denominator, so I will put it once to make your life easy. 2 multiplied by 2, 4. 3 multiplied by 3 is 9. So 4 minus 9 over 6. So you will have y to power 3 plus 1 divided by 2. It will be x to power of minus 1 over 8, y divided by x to power of minus 5 over 6, and y to power of 4 over 2, which will be 2. So I will move this up. So we'll have x to power minus 1 by 8 multiply by, or either you can move it up and make it positive, or you can just subtract it. So minus minus will be plus. So we will have plus 5 by 6. And then we have y to power of 1 plus this goes, actually this will become 2 because 4 divided by 2 is 2. So it will be 1 plus 2. So it will be, you have to take LCM, which will be 48, and 8 multiplied by 6 is 48, and 6 multiplied by 8 is 48. Or LCM is what? Are are you thinking the same way like LCM is 48? I did it because all of my students actually do this mistake. So LCM does not mean always you have to multiply them. LCM means you have to find the least common multiple, so which is 24. And 8 multiplied by 3 is 24, and 6 multiplied by 4 is 24. So you will have minus 3 plus 20 divided by 24 and y to power of 3. So you will have x minus plus, sorry, 18 over 24. And 18 over 24, it will go with the 6. It will be 6 multiplied by 3 and 6 multiplied by 4. So you will have the final answer would be x to power 3 over 4, y to power of 3. So nothing is confusing here. The thing is you have to keep everything step by step. Okay, if you want me to tell you how to make it easy in an easy way, this is the most easiest way, believe me. There is no other easy way here. Hopefully you understood this. So let's move to the next slide, which is explaining about rational exponents and radicals. So I did not write any question here. I am going to do the question. Okay, sorry, my mistake. Last question, this was converting into radical expression. So whatever the answer we had, I do not remember. So for example, if the answer was x to power of 3 by 4 and y to power of 1 over 2, I don't remember actually. Oh no, it was 3 over 2, I believe, or just 3. It was just 3. So it was just, I have to find the eraser. So it was just 3. So you would write it as fourth root of x cubed and y to power of 3. So this is the actual answer for that. Okay, let's move to the next slide, which is rational exponents and radicals. I did not write it because there are multiple topics in this lesson, which I'm going to explain. And normally, in the books and in SAT books, these lessons are not explained well. So but it is actually helping a lot my students in calculus, which is let's say if you have two exponents. Let's say we have cube root of 2 and multiply by cube root of 3. And they're asking you to write it into as one radical number. So you can see the exponent, or you can say the roots are different. It is third root, this is second root. So what you have to do, you have to convert it into exponent form, which is 1 over 3, and you have 3 1 over 2. So what you have to do actually, you have to convert it into the same root. What does it mean? How can I convert it? We don't know how to convert it into same root. It means the denominator should be same. We have learned how we can make same denominator by LCD or LCM, whatever you call it. Both are the same terms. So how can you do it? I know if I multiply this by 2 and multiply this by 3, both will give me the same answer, right? So what I will do, I just did it. 6 multiplied by 3, 1 over, sorry, it will be, uh, it was 2 over and 3 over 6. So it will be, it looks dirty, I know, it is 2 over 6. So now we have same base or same power in the denominator. So we can say it is sixth root of 2 square and 3 cube, right? I can write it simplified in this form, sixth root of 2 square, then sixth root of 3 cube. And you have to simplify it. If it is written simplification, mostly it is written that you have to simplify. They will ask you to simplify it as the final answer. So it will be 2 square is 4, multiplied by 3 cube is 927. And then you will multiply 4 with 27. It will be a big number. 7 multiplied by 4 will be 8. 2 there, 8, and 108. So this is something I think usually students do not do, but this might be helpful in calculus as well. Sometimes you have to do this back step. I did it, but it's not a very co common thing to do, so that's why normally people do not talk about these things. Then it comes when you have negative power rule, but there is power on this, and they are not asking you to convert it or multiply it with any exponent. They are just asking you to simplify it. So how can you do it? So what do you think? You have to bring a number, or it is the only one you can solve it by itself? I would say it is the only one you can solve by itself also. How? I will tell you. Let's say it is, let's divide it again, minus 1 by 3. Is it mathematically correct? What I'm doing, I'm actually back solving. You remember we read a rule that if there is such thing, you can just multiply it. So it will be 2 multiplied by 1. So it will be 2 over 3. So I'm back solving. So I know the cube root of 8, 1 by 3 is cube root, right? Or you can say it the negative 2 to power of 3 is actually negative 8. And if I will take its negative, its cube root, it will be. So this will be cancel out. We will have negative 2 square. So negative 2, negative, negative will be positive. It will be 4. And this is the simplified answer of 2 and third cube of negative 8. So I think it is clear. Let's say we have another question, which is also simplification. Let's say it is 4th and 16 over 81. Okay, so now what you will do, this is the fourth root, means it has a power of, you can see solve in a way of providing it the fourth root, but I'm not going that because I'm teaching you how we can simplify it. There's a way actually we did it when we studied square roots and other roots. How can we simplify or apply the square root itself? I'm not going in that way because I am teaching you how can you simplify when it is with the variables. Right now I'm teaching you with the numbers only. So which will be, we know it is 2 to power of 4 is and I will just use the power rule in a reverse way, and 3 to power of 4 is 81, and this will be cancelled out, so you will have 2 over 3 because this will be cancelled out, right? So I think that this was the easiest thing in this lesson, which is normally students forget. Now comes to a point where it is called rationalization. You remember I have provided you a lesson with algebraic expression how to rationalize. So rationalizing exponent functions, or you can say radical expressions. Let's say we have something called 9 over cube root of 3. In algebraic uh, questions, what we did, we'd actually rationalize something dealing with the radicals. It was, let's say, x plus 1 over square root of x plus 1 or plus x plus 1. So this was a type of question we had, and we had to rationalize it. But here we are actually having only a radical expression using the numbers. So that's why I'm not actually including that part, because that part was having addition in between and we have to rationalize it. Here, my point of explaining is I'm going to teach you when you have a rational exponent or rational radical, especially how to simplify, how to solve it. So let's say if we got this type of form, how can you simplify it? You can put in the calculator and get the answer, but in some courses, the calculator is not allowed in the exam. So how you do it? This is how you can do it. You have to learn it. So what you have to do, whatever you have in the denominator, you will just multiply and divide with the same number. Let's say it was square root of 3, so you will multiply and divide by square root of 3. So in the denominator, square root of 3 multiplied by square root of 3, you will get a 3 because it will be square and square will be cancelling the square root. And in the numerator, once you will multiply, you will get this thing, which is 9 multiplied by square root of 3. And we know 9 divided by 3 is 3. So the answer final will be 3 square root of 3. I think this was the easy one. Let's move to a bit difficult one, and I will teach you how we can solve that one when we have such cases. Not always we have to multiply, we have to think what is coming in our plate. Let's say we have this question. So now, what do you think what we are going to do? I'm giving you this time to think about it, what we are going to do before I would do something. Okay, I would say what I have to do, I have to look at it. This is a cube root, so I need something which can actually cancel a cube root from whole, or at least from the thing which is down. So what will I do? I am going to multiply it with cube root of, because the cube root should be same. If it is not same, if you are putting a fourth root or fifth root, you cannot actually merge them because they should have same power if you are going to multiply them by the power rule. So what I am going to do, I'm going to multiply with cube root of 25 a to power 2 and 25 a to power 2 in the division. Now the question comes, why did I multiply it with a to power 2 and why did I write 25 while I had a to power of 4 and we had 5? So the answer for that is, as we can see, the power is cube, right? As we can see, the power is cube. So I have to check the number with whom I would multiply and get the answer, and which will cancel at the end the last power, which is cube root. So let's say it was 4, and I have to check which is the closest number which is completely divisible by this 3. So the closest one is either 3, either I can subtract or I can add to the closest one, which is 6. And I know 4 plus 2 is 6. And also, I know 5 multiplied by 25 will give us 125, which is actually a perfect cube of 5, right? So this is how I will think in my mind. So what I will do now, I will just multiply them because they have the same radical. So 3 multiplied by 25 a square divided by 5 a square a to power of 4 multiply by 25 a to power of 2. So it will become cube root of 75 a square and divided by 125 a to power of 6. 4 plus 2 is 6. So once you will apply the cube root, the cube root will not go from the thing up because it is none of the things are actually perfect cube of something. So it will be a 75 inside the cube root with an, I don't know how I can. Mhm. I'm sorry for that. It's not actually, I'm trying to erase it. Why it is not working, I don't know. Okay, I will just use the pen. I will just, it is 75 a square, and this was the perfect cube, so it will be 5. Okay, I will write it 5 cube root of cube and a 6 of cube root. So once you will apply the cube root in the denominator, it will be a cube root of 75 a square, and here I will have 5 and a to power of 2. So this is the most simplified answer we can get from this expression. So these questions are bit long as the previous slide, but the thing is, if you go follow the same method, the method and the questions are very easy. Erase. Okay, it is not even erasing. Okay, now the most important thing which people will not discuss, imagining that the students who are entering in grade 12 or at university, they already know this, which is the basic thing of algebra is called operations with radical of same index. So what type of operations we have? We have addition, subtraction, multiplication, and division. So we already talked about the multiplication. Now we are going to talk about these 3 operations. So let's say I have 20 plus square root of 5. In multiplication, if I had same root, I can multiply the number inside, right? But in addition and subtraction, I cannot do that. I can only do it when I have same indexes inside, means whatever I have inside square root, if it is same, then I can add or subtract their coefficient because I will deal this thing as a variable. So to do that, what I would do, I will convert this one into square root of 5 because I know I cannot do anything with square root of 5. It cannot go anywhere. So I would do what is, I know 20 is 4 times 5 and plus 5. by using the basic rule again, the rules we studied earlier. So it can be square root of 4 multiplied by square root of 5 plus square root of 5. And here we know 4 is a perfect square of 2. So it will be 2 square root of 5 plus square root of 5. And as I mentioned earlier, we will consider this as variable. So I would say there is a 1 with this square root of 5 and 2 plus 1. When you have same indices or index, you will add the number before that. So it will be 2 plus 1, and you will take a square root of 5 as a common, which will be 3 square root of 5. Okay, so let's move to another question. Having a variable inside, let's say we have a cube root. Imagine this is only valid. This is only valid if you have the same index with the same this one. It should have, it should be same root and it should be same inside the root. Let's say we have 24x and let's say a subtraction one because we already did the addition one. It is, let's say, 81 of x. Okay, so I know this 24 goes as 8 multiplied by 3, and this 81 goes like 27 multiplied by 3. So 3 is a common thing, so I will be converting it into a 3. Why? I know 8 is a perfect cube of something, and 27 is also a perfect cube of something. So I would say this is a thing you will be thinking in your mind. You will not do it. Either you are solving, you can do it as your rough work. So it will be cube root of 8 multiplied by cube root of 3 into x minus cube root of 27 into cube root of 3x. So it will be 2 cube root of 3x minus 3 cube root of 3x. Now we have same indices. The coefficients will be added or subtracted depending on the sign in between. So here is negative sign. 2 minus 3 is minus 1. So it will be minus cube root of 3x, and minus is not with the cube. Minus is actually on the number itself. Hopefully it is clear to you. Let's do the last question for this lesson, which is by division. So let me clear it, the board. Let's say we'll take one question. This is easy, so I'm not going to have more questions. Let's say it is 40, let's say divided by 5. The same thing what we have to do, the same concept what we will do here. So I would say this is 8 multiplied by 5 divided by 5. And in division, you know their power should be added or subtracted. So it will be square root of 8 is the final answer because this 5 will be divided and it will give you 1. So that's it. This is how you would deal with multiplication and division. Multiplication and division easy. Students usually do not do much mistakes in multiplication and division. Rather, they do a lot of mistakes when adding or subtracting. Hopefully, you understood the concepts of exponents and radical and how we can convert it, how we can make them into simplified form. Let's meet in another video with the next lesson. Till that time, take care. Try to analyze your mathematical concept, revise them before you actually start digging calculus, or if you have already started and feeling some difficulties, I would suggest first go and revise some topics to help you deal with this calculus. And if you have got any question, you can just write in the comments or send me email at mathwithhafiz, math with hafiz @gmail.com. And if you are looking for private session in UK or you are looking something online, I'm always there to you to help you out and bring the fear out of you of not understanding mathematics. Bye. Take care. See you next time.